Hello, my stats friends. So this is a little strange, but very much like math. We are actually going to start our stats whole class. We're going to start it in chapter 4. So I hope this doesn't disappoint anybody, but chapter 4 has actually very little math calculations, and it's all about this beginning part is collecting data. And you may have a little bit of experience with this in your algebra classes, or maybe some of you took pre-calc, so you have a little exposure to this. And frankly, just day-to-day life, you're going to see a lot of terms and words, phrases, vocabulary that you've run into before. So the big push for chapter 4 is that we really harness in our vocabulary and we use it properly. So anyone out there who isn't familiar with our class, we are using um, the Starnes and Tabor Understanding Statistics book. So these are the um, PowerPoint presentations that align with those questions. And it is from the 6E updated edition, if you're curious. All right. So I don't usually use PowerPoint in math. This is a wild change for me. So our learning targets, we have quite a few even in this first section. But like I said, there's several things here that are going to seem very familiar. So that's wonderful. All right, so first, some vocabulary. So if we are trying to collect some data, it's because we want to know about an entire population. So the population is, I hate to read to you, but here we go. A statistical study is the entire group of individuals that we want information about. So maybe you want to know something about every single student who takes the AP Stats exam in May. Well, it might not be feasible for us to collect data on every single kid. So maybe what we have to do, um, because that would be called a census, by the way. So if you're collecting data on every single individual, it's a census. That word might be familiar to you because there's like the government census. And of course, we know that that's not necessarily a census because they really can't talk to everybody because frankly, some people just don't answer their door or their phone. So what do you do then? So then you get a sample, and a sample is a subset of individuals from that population. So the whole goal of this is if we do this correctly, if we sample correctly, the findings that we find with our sample, also terrible use of English, is going to be able to relay to the population. That's the idea, if we do it correctly. So population, everybody, sample, a part of that. So we're going to collect our data from what we call a representative sample, and that's kind of the key. And that allows us to come back and make an inference or conclusion about the population. Now, what you'll learn about stats is nothing is ever said in a concrete manner. We'll say things like, oh, we have an inference, we can conclude with slight, with certainty. No, that's not, we never do anything with certainty in stats. All right, so we often draw conclusions about a whole population on the basis of the sample. So choosing a sample that is large and varied, it's actually not that easy. So something I know you all have partaken in is a sample survey. So you're going to collect data from a sample that is chosen, and hopefully that sample represents the entire population. So all of those surveys they send out to you in your email. That's the kind of idea they're talking about. Now we send them out to every single student typically, but in this case, when we have a sample survey, it's because we can't possibly sample and survey, excuse me, every single person. So we have to decide what exactly is your population, and then we want to make sure we know what we're measuring, and we have to figure out how are we going to choose that sample. So this is kind of fun. How do we do this badly? Well, there's something called a convenience sample. And in math, we tend to name things what they are, and stats is no different. So a convenience sample is just you are picking people or getting information from people who are, or subjects that are convenient to you. So the example is, someone wants to know something about your opinions on lunch. So I stand at the door and I just ask the first 100 kids that walk in, what are your thoughts? Is that a good sample of the entire population of the building? No, it was a convenience sample. I really doubt that those 100 kids that I talked to really definitively represent the population of your school. So convenience sampling produces unrepresentative data, which is a way for us to bias our results. So there's a vocab word I know you've seen. So the design will show bias if it is very likely that you either underestimate or possibly overestimate some information because you have missed an entire part of the population. So, for instance, if I ask that same question about what are your opinion, maybe I'm surveying everybody about their opinions of lunch, and I stand at the doorway, but I stand at the doorway, right after school. Well, I'm not getting a good representation of every single kid because depending on what door I stand at, if I stand at the athletic entrance, maybe I'm only getting the opinions of our athletes. If I stand at the main entrance, maybe I'm only getting the opinions of students who ride the bus, which that might be a representative population, but I don't think I can conclude that right now. So I need to do a better job, is the idea, because we're going to have some bias in our results. So bias it's not just bad luck from one sample. It's just you've done a bad job, and we want to avoid bias whenever possible. It's kind of fun when we look in the news and we think about, oh, how is this done, and how can we identify the bias? Because if you watch news channels, depending on which one you're watching, you can see the bias. You can see, oh, who answered their questions? Well, their viewers answered their questions. Well, who watches that channel? People who find that they agree with their views. So a lot of the information that are done with surveys is just biased because of that. All right, so convenience sampling will almost always result in bias, so it's just a bad idea. But there's something called voluntary response sampling. And this allows people to choose whether or not they're going to respond simply by invitation. So often that is it. It's a little hard to see. You guys probably don't get too much mail at home as a student, but there's a lot of voluntary response sampling in your general mail. Fill out this survey and send it in. Maybe in your email you've gotten that before. I just did a refi on my mortgage, and they sent an email with like, tell us how we did kind of a thing. And they tried to incentivize it by saying, we'll put you in a drawing for $1,000. Well, you know, I really enjoyed my experience with that company, so I volunteered essentially to respond to that to that survey. And maybe someone who didn't have a good experience would volunteer to return their response. But someone who didn't really care was kind of like, whatever, it was fine. They're not going to bother to fill that out. So a voluntary response sampling can often introduce bias as well because you're only getting the information from people who want to respond. So most internet polls, call in, text in, write in polls, they're voluntary responses. So if you self-select to participate in the survey, it's not necessarily going to be representative of the whole population because there's a huge amount of people out there who probably didn't care to respond, but we're missing them. So here, your book is so wonderful about AP exam tips. The authors of Starnes and Tabor are really, really good at kind of pointing out moments in our learning. We're like, hey, don't forget about this. So if you're going to be asked to describe how to design a sample survey, how it would lead to bias, you're going to want to look for two things. So describe how the members of the sample might respond differently than the rest of the population, and explain how this difference would lead to either an underestimate or an overestimate. And that's really key. And we'll see some examples of this later on. You have to be really, really specific. So saying things like, it will overestimate the amount of people who support this cause because of, and that's one thing that I remember someone telling me to kind of warn you guys about. A lot of kids are not very careful with how they answer that question, and they might contradict themselves in that question. So they might say things like, oh, it's going to report bias because it's going to overestimate, and then they say the wrong thing. So just be careful what we're writing. You might find pretty soon that I was trying to explain this to a kid before. What is stats? Stats class is kind of like if a math class tried to be an English class. Like there's a lot of that in there, so we got to be careful how we're writing. All right, so let's see their example here. I kind of lost my train of thought. Suppose you were asked to explain how using your statistics class as a sample to estimate the proportion of all students who own a graphing calculator could result in bias. You might respond, this is a convenience sample. So you've identified what it was, and it would probably include a much higher proportion, so an overrepresentation of students with a graphing calculator than the whole population. because graphing calculators are required for the stats class. And that's not really true for our class, but a lot of you do have a graphing calculator just because of the math you've taken. So this method would probably lead to an overestimate. So there's that keyword they're looking for of the actual population proportion. So we have overestimated the number of people who have graphing calculators because of how we did our sampling. It was convenience, it was no good. All right, so there's that idea about bias. It's not just one sample of bad luck. It's consistently going to miss the truth. I like the way they said that. All right, so this is a check your understanding question. In class, we're going to like stop and actually do these and like want to maybe talk to a partner. I don't know, we'll try that. The following situations identify the sampling method that was used and explain how bias in the sampling method could affect the results. So here we have a farmer of a juice company. He gets several crates of oranges. A company inspector looks at 10 oranges from the top of each crate before deciding whether to buy all the oranges. So you're going to learn this pretty quick, but my next slide is going to have the answer. So I highlighted some important pieces there. It says the company inspector is using a convenience sample. This could lead him to overestimate the quality of oranges, and we can go on and explain why. Maybe he puts the best oranges on top. That makes sense to me. If I want someone who's going to pop the lid open and look at nasty oranges, they might not buy it. And maybe the oranges that are actually on the bottom are damaged and don't like they aren't really juicy maybe, or maybe they're moldy at that point. So if you're just sampling from the top of the box, it's going to overestimate the quality of the oranges. So back up a minute, Abruzzo. I haven't used PowerPoint in a while. I forget how to do this. All right, the ABC program Nightline once asked if the United Nations should continue to have its headquarters in the United States. Viewers were invited to call one telephone number to respond yes or no. There was a charge for calling either number. Okay, that gets worse. More than 186,000 callers responded, and 67% of them said no. Okay, so this is a voluntary response sample because they had to like say to themselves, "Self, I really want to like make this phone call." And remember, they're being charged for that phone call, which cracks me up. So they must be very, very passionate, feel very strongly about this issue. Um, and in this case, if you're happy that the United Nations has its headquarters in the US, it's already what is happening. So like they're not going to call up and say like, darn it, I need things to say exactly the same way they are. Like people don't do that. But if your passion is because you want something to change, then you might be more likely to call in. So the proportion who answered no in the sample is going to be higher. They have an overestimate than the true proportion. So they didn't necessarily use the phrase overestimate or underestimate here because that word can change depending on your context, but they very clearly defined in this answer what will be out of whack essentially, to use a very non-mathy term. Now, the reason there's a big blue block here is because this is probably going to be the end of our first day's lecture. So if you're one of my students, this might be where you stop the video, but I'm going to keep on trucking because why not? So this is a activity that we're going to do in class, and it was adapted from StatsMedic, one of my favorite websites. We're going to kind of preview some different sampling methods. So for now, for this video, the overview video, I'm going to skip it. We'll get to those vocab words in a moment. So a sample is chosen by chance, rules out both favoritism by the sampler and the self-selection by respondents. So that was, the convenience sampling. It's not always in a frame of favoritism, but I'm sure we can envision a way of where it would look like favoritism. And also the self-selection, the voluntary response, like that created a big problem in the previous lesson. So if we do a sample chosen by chance, which is called a simple random sample, then we're going to get what we need. That's the idea. It's going to represent the true population. So random sampling involves using chance process to determine which members of a population are included in the sample. So even though to like your human brain, you might think, you know what? It's not going to make a difference if I just choose the first 100 people who walk in the door. Statistically speaking, it sure does. You are not going to get a representative. Well, I'll say it this way. It's very unlikely that you're going to get a true representation of the population if you convenience sample or do a voluntary response sample like we saw in the previous part of the lesson. So from henceforth, SRS stands for simple random sample. Mathematicians don't like to write words if they can abbreviate it, so just know SRS stands for that. Of size n is chosen in a way that every group of n individuals in the population has an equally likely chance of being selected. So regardless of who you are, what you do, where you're located, you have an equally likely chance of being selected. So if I go back to that example about the oranges that were in the crate, that person was just choosing the ones on top. So the ones in the rows underneath the top row had no chance of being selected. So that was definitely not a simple random sample. But we strive for simple random samples. So how to choose a simple random sample with technology? Well, it's not always with technology. There's pretty much three methods that we're going to talk about. And this first here, it says label. Now, I know this seems like overkill because you're thinking, well, of course I would label them. How else would I figure this out? Whatever you have as a population has to be somehow structured with labels. So if I in a minute, we'll see a random number generator and it says choose number 7. Like I have to know who number 7 is. So we have to figure that out in a moment. So give them all a label 1 to n, where n is the total number. So if you have 5,328 people, you're going to have integers from 1 to 5,328. And then you're going to randomize it by using, in this case with technology, a random number generator, we'll show that in a moment, to obtain different integers n, where I will get what I want as a sample size. Now notice they use uppercase n for the population and lowercase n for the sample. That's notation we will get used to. And then we do have to talk in a moment about repetition. In most of these selections, you don't want to have repetition. So like if I was so unlucky that I was choosing numbers and I got 7, and then a few minutes later I got 7 again, typically we don't want to have repetition, and we'll talk about how we mitigate that. So choose the individuals and line them up with who they are and ask them your questions. So here we have the technology corner, and notice this little arrow here. That means in your online textbook, there's a video going over everything. So if you ever get lost on this part, you can go visit that. And I'm sure there's 4,000 different videos on YouTube of how to do this as well. Okay, so for us, we are going to want to choose a simple random sample of 10 students, and our population is 1,750. So this cracks me up. So we would number our students 1 to 1750. Now, typically when you have a population like this, a student population, you have some sort of an alphabetized list, and it's in some sort of a Google Sheet or something where you could just carry a formula down and number them. Pretty simple. Okay, so for us, again, I hate to read to you, but here we are. We're going to press the math key, and then we're going to go over to probability. Now, there's a couple of different options. They chose random integer, but we'll show you in class that we have some other options. We have random integer, no repetition. That kind of makes more sense for most of the times when we're choosing an SRS, because that means they're going to eliminate any sort of repetition. So if 7 shows up once, twice, 3 times, it's not going to count it. Now, the other thing that we'll show you in class is that if I wanted 10, I would do exactly what they have here, where it says get 10 distinct integers, and it's going to just list them out. It's going to paste them into my calculator. It's wonderful. Other places it can paste it, like in tables, that might be useful to you, or if you're using a different program, sometimes you can paste them into like a Google Sheet type of, or an Excel type of file. So we'll show all of this, but notice on their example for the screenshot, they went and they did this cute little thing. They just kept hitting enter, 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 enter until they got 10 different people. So we'll do a lot of that in class. You guys will love that method. And what I've learned this summer as I was going through many, many, many AP Stats questions, they don't mind when you use calculators on questions like that. The problem is you have to clearly define what you did. So whatever command you pull up, you have to pull it up. You have to write it down on your answer. And you also have to very clearly indicate, what did you do? I used a, you know, start value of 1 and ending value of 1,750. And you also have to mention things like I labeled all of the population from 1 to 1750. Like you got to get real specific. We'll do a lot of examples of that. All right, so technology, we love it. Sometimes in Algebra 2, kids would get lazy and they would just tell me things like, I used a random number generator. Like that's not going to cut it in Prob and Stats or in AP Stats. So we have to get real specific. Now, if you don't want to use technology, you can use a good old-fashioned table. This is back in one of those back in my day moments. And that's a lie, because back in my day we did have calculators like this. I'm not that old. But before my day, they didn't have that, and they had to use what's called Table D. It's in the back of your textbook. It's also listed in various packets that you'll be given for formulas, and on the AP Stats test, there is a Table D in your formula packet. So, same idea. We start the same way. We give a number distinction to every single thing, and you want to use as few digits as possible. So, in that case they had previous, that 1750, we'd have to label them with 4 digits. I think the example we're going to see in a minute doesn't do that same one, so we'll hang on to that. Then we're going to go visit table D, and we're going to read consecutive groups of digits of appropriate length from left to right. And this has always kind of like perplexed me. You're just supposed to start somewhere on the table. Like it doesn't really matter as far as what row you start on. Sometimes they'll tell you where to start just so like a teacher can have the same answers pop up for every kid. Um, but if you're randomizing, like it doesn't really matter, right? So, and then you line them up and say, here's the 10 people I chose or whatever, and then you go from there. So here is an example, and if you're from my class, you have some notes where basically there's like one page and my slides are going to kind of follow along with the process. So do this part with me. So what we did is we have a whole bunch of hotels here. We have 28 hotels. So first we've done is we've labeled them 1 to 28. Notice we use 2 digits. Even the single digit ones have 2 digits. There they are. They're assigned to a label. So now we're going to go visit table D, and it says use line 130. I don't know who chose the 130, but whatever. There's line 130. So this is straight off of the table. And next, what we're going to do, because we have 2 digits, we're going to group these by 2 digits. So notice what we did here: 69, 05, 16, 48, and so on and so on and so on. So now, as we read across from left to right, we see who is a winner, if you want to think of it that way. So remember, we're trying to choose 4 hotels. So as soon as we get 4, we're going to stop this process. So 69, that is not in my list. I end at 28, so no good. 5, Beach Castle. Yeah, keep it. All right, 16, Radisson, of course, keep it. 48, not in the list. Ignore it. 17, Ramada. 87, not there. And then so on and so on. So we hit 17. Now notice we hit 17 again, and then 20. So because we hit 17, boom, 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 3 times, we kind of ignored it, and then finally we got to number 20, which is going to be our last hotel. Remember, we wanted 4 without repetition. So we would have to specify that on our AP Stats test that we ignored any repetition. And we are going to choose Beach Castle, Radisson, Ramada, and Sea Club. Wasn't that fun? That was very much a back in my day moment, huh? All right, so a furniture maker buys hardwood in batches that contain 1,000 pieces. The supplier is supposed to dry the wood before shipping. Wood that isn't dry won't hold its shape and size. Furniture maker chooses 5 pieces of wood from each batch and tests their moisture content. If any piece exceeds 12%, the whole batch is going to get sent back. So describe how we would select a simple random sample of 5 pieces. And they want you to do both methods. So we got to kind of be prepared for anything for our stats test. And that's the way we approach this class. We're always prepared for anything. So you're going to see homework questions where maybe we ask you to do it, the old way without technology and sometimes with technology. So first, they wanted a random number generator. So again, I'm kind of cheating. I'm going to show you the answer here. I did some highlighting. So remember, 3 things, right? Label, randomize, select. So first thing we would do is, and this cracks me up because we'd have to do this, label the number of pieces of wood, the pieces of wood from 1 to 1,000. I don't know how you're doing that, but all you got to do as a stats person is say, okay, well, we're going to label them. And then we're going to randomize by using, now notice the words here, the command, and they went with random integer 1 to 1,000. But remember, we saw that random integer no repeat. So on a AP test, we're going to be real specific about what we're doing and what we're using. and we're selecting 5. So once we select 5, then you got to take it all the way home here, guys. We're going to inspect the 5 pieces of wood that correspond with those numbers that we selected. Now you could even go further and say what you're going to do after that point. Once we've selected the 5 pieces of wood and inspected them, if any of them exceed 12% moisture content, we got to report that back. All right, but that was a little extra. We didn't have to do that. All right, so now they wanted a table of random digits. So because we had, oh, this is cute. All right, so they got a little crafty here. Instead of labeling 1 to 1,000 because they didn't want to use 4 digits, they went 000 to 999. Oh my gosh, mathematicians, you are so lazy. All right, so because of that, they were able to label 3 digits. And they weren't real specific here as to what they did. They didn't show like what line in the table they did, but basically you would choose a line from table D. You would move along the digits, reading off 3-digit numbers from left to right until you found 5 that could be selected. And then once you have your 5, you would go inspect those 5 pieces of wood. So this is kind of fun to do in class because depending on who uses what line in the table, we definitely get a random sample, which is what we want. So one of the most common alternatives to simple random sampling is stratified random sampling. And this is probably, just FYI, probably the next day. So just keep that in mind if you're watching for class. So strata are groups of individuals in the population who happen to share characteristics and might be associated with what we're actually measuring. So if you think of your school, maybe you want to group certain students together, maybe by class. Maybe you want a strata of freshmen, a strata of sophomores, a strata of juniors, and a strata of seniors because their response to my survey might be different based on what grade level they're in. Maybe freshmen don't care about the parking lot because, darn it, they don't drive. Things like that. So a stratified random sampling selects a sample by choosing an SRS, but within the stratum. And then you take your stratums, whatever they are, and you push them together at the end. So that example I was just using with students, if you needed a sample of 100 students and you wanted to include all 4 classes as strata, you would have to divide that by 4, of course, and then say, I'm going to choose 25 freshmen, 25 sophomores, 25 juniors, and 25 seniors. So that, my friends, is stratified sampling. It works best when individuals within the stratum are homogeneous, so they're similar with respect to what is being measured. They don't have to be similar like across the board, but if we're asking them, like my dumb example I just flew off the top of my head with, your opinions on how we do parking stickers. Freshmen probably have a different answer to that than your seniors. So at least they're going to have, that was a really bad example, by the way. At least they're going to have their own strata we can kind of dive deeper into, and we can combine the strata together. All right. So the might have similar responses within the strata, but different responses between the strata. Okay, so that's going to give you a more precise estimate of the actual population. It would be unfortunate. Oh, this is probably where we end. It would be unfortunate if we didn't stratify the sampling and found out that we just happened to have a sample that only included seniors and only included their opinion, or even worse, it only included freshmen's opinion. Sorry, freshmen. I say bad things about freshmen sometimes, but come on, they're freshmen. We're going to revisit that Justin Timberlake example as a preview for this lesson on this third day now of 4.1. But let's get into the vocab here. There are even more sampling methods. Woo! When populations are large and spread out over a wide area, we prefer a method that selects groups, we call them clusters, of individuals that are near one another. This is called cluster sampling. Again, math pat on the back for naming things that are super obvious. A cluster is a group of individuals in the population that are located near each other, and cluster sampling selects them by randomly choosing clusters and including each member of the selected cluster in the sample. So this is different than stratified sampling. This is a little confusing to kids. Stratified sampling is where you're choosing from which within each strata. Cluster is you're randomly choosing one of the clusters and just going for that one. And you're going to interview, survey, whatever, every single person in that cluster. There is a great activity that you guys, I think you may have already watched it if you're in my class, but it's from Skew the Script. And it talks about how the different types of sampling can affect um, answers to surveys within demographics of cities and how that can lead to, socioeconomic bias, political bias, racial bias, all sorts of good stuff. All right, actually bad stuff, but it's good for us to look at the data. All right, cluster sampling works best when the individuals are heterogeneous, so they should mirror the population. So your cluster is an amalgamation of everything. So to bring it back to something that's more local to you, rather than going to what's a good example of this? It's tough in high school because we do kind of sector you guys a lot. That's terrible now that I think of it. Oh, I know. Band and choir. You're gonna kind of get everybody in band and choir, right? Maybe. I don't know if that's true anymore. You're not just going to get freshmen, sophomores, juniors, seniors. You're going to get a little bit of everybody. I guess that's not true if you look at the upper level ones, but all right, work with me here, guys. PE class. There's a great equalizer, right? Everybody's in a PE class. Almost. I guess high school is not the best example. All right, cluster sampling is often used for practical reasons, and it's going to save you time and money, which I know you don't worry about that right now as an AP Stat student, but if you were doing this as a job, you don't have the time, the resources, the money to fly around the country and interview every single person. It's just not going to happen. All right, another way to choose a sample by random chance is called systematic random sampling. This one is very robotic and I kind of love it, but it doesn't always work, but it's an idea. So it selects from an ordered arrangement. So it's the idea of selecting every fifth person that walks in the door. That's called a systematic random sample. The idea is if you make it systematic enough, I should say, it's going to be random because you're not going to get groups of like-minded people together or friends, um, and hopefully that helps with your data so that way you can claim that your responses were not biased in any way. So systematic sampling, I think we've seen that a lot in life. Robocalls are sort of systematic, although they kind of try to get everybody, but they go in order of like, okay, I'm going to go obviously these aren't people doing it, but the machine goes through a list of phone numbers and it like calls them in some sort of a pattern. I'm sure you've noticed this if you have a cell phone. All right, systematic random sampling in particular is useful in certain contexts, such as exit polling at a polling place. So they can't possibly stop every single person who's leaving on election day, but they know that if they can systematically try to stop every 17th person, I don't know, I'm making that up, that their responses will be random enough where it truly represents the people who walked out of that polling place on election day. However, in recent years, we've seen how polling and surveying isn't always as predictable as one would hope. All right, so here's caution for you. If there are any sort of patterns in the way that the population is ordered that happen to coincide with the pattern in the system, you're going to have some weird representation. Okay, it's not going to be representative of the population. The example I use for this is So, gosh, I always try to make a kid example, but I have a hard time because apparently I'm not hip with the generation anymore, guys. Oh, there goes my cell phone though. Okay, so what if I wanted to figure out, my daily pay if I was a teenager and I worked at, where do you guys work these days? Starbucks has always been my dream job. Starbucks. My daily pay, and I systematically chose every seventh day that I, was on the calendar. Well, that's dumb of me because I'm looking at a calendar and it goes in a rotation of 7. So if I happen to start on a Saturday where I probably work a whole lot of hours, I'm going to keep hitting Saturdays every time I systematically go through a rotation of 7. So that was silly of me. That was a terrible way to sample. That was a bad example. What do you know? All right, so check your understanding. A factory runs 24 hours a day. Okay, this problem, I have to like sit down and draw it out. It's got a lot of info in it. It's producing wood pencils on 3 8-hour shifts, day, evening, overnight. All right, cool. In the last stage of manufacturing, the pencils are packaged in boxes of 10 pencils, and each day they must sample 300 pencils to make sure that they are of the utmost quality. I don't know what they do if there's bad quality, but they got to select and check them out. So the first example, we're going to talk about how we can make what's called a stratified random sample for the 300 pencils. And then the next question, we'll talk about how to do a cluster sample. And then the third is the benefit, and actually I think there's another question in the answer key, but a benefit to using stratified random sample and the benefit to using a cluster sample. So, um, because the quality of pencils might be the same within each of the shifts, because I don't know if you have workers or maybe the machines are all kind of working the same, but they might differ between the shifts. You could use the shift as a strata. So we said it was, morning, afternoon, and evening. So at the end of each of those 8-hour shifts, stop what you're doing, label all the pencils produced, which I think is crazy, during that shift, and it'll be 5,000 pencils. I guess, yeah, there was information back here, wasn't there? Yeah, okay. Boxes of 10. I don't know. Did they ever tell us that? I feel like we made up that number. I don't know. Whatever. It's okay. So now we're going to generate 100 different random integers and select them for inspection. Now remember, the goal was to inspect 300 pencils, but since we're doing the strata, we have 3 different strata. So it's 100 from the morning, 100 from the afternoon, and 100 from the overnight or evening or whatever. I forgot what they called it. So that'll give us the sample of 300. So there's stratified sampling. Now for cluster, they claim that the boxes of the pencils could be used as clusters. So remember how they're packaging the pencils together into boxes? So at the end of the day, label all of the boxes from 1 to 1500. Again, I don't know. I feel like that I missed that number somewhere. I don't know. I'm sure you guys in class will point it out to me. And then we're going to generate 30 different random integers that we didn't specify how, but I'm guessing we're using a random number generator from 1 to 1500 and inspect all of the pencils in those boxes. So, if it pulls up box 49, 58, 7, 7's my favorite number apparently. Those are the boxes that we go grab and we inspect them. And that will give us our sample of 300 because remember, 30 boxes times 10 would be 300. So the last question there was about the benefit of each of those. So a benefit of using stratified sampling, remember we're doing it at the end of each shift. Um, it'll lead to a more precise estimate of the overall quality throughout the day. But also, it'll tell you if there's a problem from one shift to the other. So this is used a lot in when there's humans involved in the manufacturing and machines, because sometimes the humans are the problem, and sometimes the machines are the problem. So that's something to think about for stratified sampling. While we are going to put the results together to get an overall estimate, you could also kind of separate them and keep them separated into strata and compare within the strata or between the strata. So the benefit to using a cluster sample is that it simplifies the sampling process. Like how hard is, well, I don't know. I think it's pretty hard to label all those boxes, but whatever. So it wasn't difficult for us at the end of the day to go pull out 30 boxes of pencils and say, here's our sample. It's much simpler to find 30 boxes at the end of the day than individually selecting 300 individual pencils throughout the day and keeping track of all that. I don't know whose job that is, but it sounds awful. Now, the one they didn't mention that I think is worth looking at, a systematic random sample. So bear with me for a minute, a little bit of math. We got 15,000 pencils, right? Where did they get that number? I feel like I totally missed this. 300 pencils? That's a sample, 8-hour shifts. I nowhere here do I see that number. I don't know. I must be missing something. Okay, anywho, they're making stuff up, I think. 15,000 pencils that are made per day, and our desired sample size is 300. So little division here. If you cut that by 300, you get 50. So 50th, every 50th pencil would be a great way to look at it. Now, I love this. For simplicity, we select every 50th pencil that comes off the production line. That's perfect. So I don't know if like fireworks go off or what, but every time a 50th pencil comes through, they stop the machine, they grab the pencil, they check it out. This is actually very much how quality control is done in many manufacturing settings because it's easy for them to kind of look at what's going on. And also, the benefit to systematic in this case and all manufacturing is as they're coming off the production line, if you run into an issue, you're like, oh my goodness, none of these pencils have erasers. You stop the production and you fix the issue. Rather than waiting to the end of the day to find out, 3/4 of your pencils don't have erasers, that would be a bummer. So you stop and you figure it out right away. So there's a definite benefit to systematic random sampling, especially in a manufacturing setting. So this is always fun for everybody. What can go wrong with sample surveys? All right, so the use of bad sampling methods often leads to bias. Researchers can avoid these by using random sampling to choose their samples. That's what we've been talking about this whole time. However, and this one's really fun, other problems can occur. Other problems in conducting sample surveys are more difficult to avoid. Let's talk about this. So, undercoverage. This would be when some members of the population are less likely to be chosen. So, this is kind of under the umbrella of bias. What have you done in your sampling that doesn't allow a certain group of the population to be selected? And there's a lot of social issues that come up with this. Your survey, your data, what you're basing everything on. Voting, for example, is some could argue in some cases there's an undercoverage issue of certain groups of people because voting has become difficult in some counties for certain people based on how their life is going at the moment. Can you only vote during certain hours of the day? Do you have to be able to wait in line for 17 hours? So people who have to work and cannot take off work could not vote in the past, so that's why a lot of people were fans of the mail-in voting. All right, non-response. Now, this is different than voluntary response. Non-response is when an individual chosen for a sample cannot be contacted or, frankly, refuses to participate. So, robocalls get a lot of not responses, right? The robocall things will call, especially you guys probably don't get these yet because you're too young, but during election time, oh my goodness, so many calls. And they're not robos all the time. Sometimes they're people, but they want to know everything about you. Who you voting for? What do you think? And you know what? You just don't want to answer them. So you get a lot of non-responses there. And response bias is where there's a systematic pattern of inaccurate answers to a survey question. So that's interesting. And this is a word of warning here. Some students misuse the term voluntary response with non-response. We just talked about that and how they're not the same thing. All right, let's check our understanding. So, name the type of bias. This is fun. All right, the sample is chosen at random from a telephone directory. All right, kids, we need to have a little history lesson for a moment. Did you know that there's such a thing as a telephone directory? Yeah, there used to be like a telephone book and everything. In fact, I think they still exist. You may have never seen one before. But, and that, I'm kind of leading you to the right answer. We'll talk about that in a minute. Some people cannot be contacted in 5 calls. Okay. Um, and then interviewers choose people walking by on the sidewalk to interview. All right, so what type of bias did we just incur? So that first one, the telephone directory, that is going to result in undercoverage because anybody who is not listed in the phone book, again, you guys don't know what this means. So you could opt to have your number not listed. They call it unlisted in the white pages. So that way no one could look up your phone number. That used to be a really big deal as a teacher. Like you didn't want kids to find out your phone number at home. Well, turns out, guys, nobody has home phones anymore. So we don't really worry about this. But under coverage, anybody who's unlisted would not be covered. So then the second example, which I already forgot what it was, some people cannot be contacted in 5 calls. So that would be a non-response. That would be the person who, has either the robocall or something and they just block it or they hang up. So they are not responding to it and therefore it's a non-response. And then this last one where people just walking on by, that is a convenience sample, which will lead to undercoverage again. People who are not walking on the street don't have the opportunity to even be chosen. Like, get out there, man. Don't just stand on the street. All right. This question, which, oh, yep, we got an answer coming up. A survey paid for by makers of disposable diapers found that 84% of the sample opposed banning disposable diapers. So they said, no, let me have my diapers, I guess. Now, as a former infant parent, my children are not infants anymore. I'm going to be honest. I really wanted to save the earth and not have disposable diapers, but gosh, guys, I can't even tell you how many diapers you go through. You just get a little lazy. I don't know, lazy's not the right word. I'm sorry. You got to have a little convenience in your life when your infant's screaming and peeing all over the place. Anywho, I digress. All right, so 84% of the sample said, no, do not ban my disposable diapers. But here's how they worded the question. It is estimated that disposable diapers account for less than 2% of the trash in today's landfills. In contrast, beverage containers, third class mail, and yard waste are estimated to account for about 21% of the trash in landfills. Given this, in your opinion, would it be fair to ban disposable diapers? So, do you think that 84% is less than, greater than, or equal to the percent of people in the whole population who actually oppose banning disposable diapers? And explain your reasoning. So, this is where, if it was an AP question, you got to be real careful how you answer this because people will choose in their brain it makes sense. When they write it down, it doesn't make sense. So, the 84% is greater than the percent of all people in the population who would actually oppose banning disposable diapers. Okay. So remember the way they worded that question, they basically were like, diapers rule, everything else is the problem. So after reading that question, me as a mommy, I'm like, okay, well, I guess I don't feel so bad about, keeping my nasty disposable diapers, throwing them in the trash. So I would say, no, I don't want to ban disposable diapers. And had they worded the question differently, we would get a more accurate representation of the population. Not to be, it's possible that 84% is right, but the way they worded it, it definitely opened the door to bias. So the proportion who would say yes to the survey is probably going to be smaller than, it would be smaller than the proportion who would say yes to a more fairly worded question. That's worded weird, sorry. Speaking of wording. So if they worded the question more appropriately, I have a feeling that 84% would get knocked down. So is it representative of the entire population? Probably not. We introduced a little bias. All right, kiddos, that is the end. If you watched that whole video, good for you, but that was 3 days, at least 3 days worth of AP stats. So we had a lot of vocabulary there. You're going to have a lot of practice problems. And remember, the key is vocab and using it properly. So I'm not looking for essays when we write these answers, but I want to make sure the vocabulary is there. You are writing clear sentences, clear thoughts. Speaking of clear, we got to practice our handwriting, guys. And I know I'm the last person who should complain about handwriting, but that's how you got to answer the AP test. So we got to work on all these little things as we progress through AP stats. Thanks for joining me in this. I had a good time.